So to round out this section, I want to talk about one more type of problem. This is where a double integral has already been set up for you as either type 1 or type 2, but it should have been set up as the other type. So the process is referred to as reversing the order of integration. So again, this applies to regions that are set up as one type, either type 1 or type 2, but look better as the other type, either type 2 or type 1, respectively. So the example that I have for you is the double integral from 0 to 1 and the square root of x to 1 of the square root of y cubed plus 1 dy dx. So first and foremost, the ability to identify that you want to reverse the order of integration. This is set up as the square root of y cubed plus 1, and we're integrating with respect to y. I have no idea what the antiderivative of the square root of y cubed plus 1 would be, because I can't do a substitution with it. This isn't a perfect square, so I can't do trigonometric substitution. Overall, it's just not going to work out particularly well. So what I'm going to do is interpret this as the kind of region that it is. This is based on the order of the integration that I see. We're going y first between functions of x, and then x is between two constants. That lets me know that this is a type 1 region. Based on the bounds that are set up, y would be between the square root of x and 1, and x would go from 0 to 1. I want to sketch this region because I want to convert it to a type 2 region. So let's sketch all of these boundary curves. Y equals the square root of x looks kind of like this. Here's y equals the square root of x. So that's the below function. The above function is going to be y equals 1. That's just going to be a horizontal line. Y equals 1. And then x goes from 0 to 1. Now this point of intersection that we have right here would be the ordered pair 1, 1. So here is x equals 1. Now again, square root function is below, 1 is above. The region in question would be this region right here. So again, square root of x is below, y equals 1 is above. I would like to convert this to a type 2 region. For a type 2 region, we're supposed to be thinking of this as going from left to right first and bounding functions of y. Now as far as that's concerned, the function on the left is the y-axis. That would be x is equal to 0. And the function on the right is our parabola that we have. However, it's not in the correct form because it needs to be in the form x equals. So, solving this for x lets me know that x is going to be equal to y squared. So our right bound is x equals y squared. Then y will go from a constant to a constant. The lower constant is 0, the upper constant is 1, because again, the point of intersection is 1, 1. So this lets me know that the integral from 0 to 1 and the integral from square root of x to 1 of the square root of y cubed plus 1 dy dx, this is your type 1 integral, is equal to, let's set it up using this. Y goes from 0 to 1 and x goes from 0 to y squared of the square root of y cubed plus 1. Note the order. This will now be dx dy. And again, we'll indicate what is corresponding to what. Now, integrating this thing with respect to x is going to be a piece of cake due to the fact that all of this would then be a constant with respect to x. So this is going to be x times the square root of y cubed plus 1, since that is the integral of a constant. Then, plugging in our bounds, when we plug in that lower bound of 0, everything is going to 0 out, so we'll just go ahead and skip that part. This will be y squared times the square root of y cubed plus 1 dy. This can be evaluated much more simply using a substitution. We'll say let u be equal to y cubed plus 1. Therefore, du will be equal to 3y squared dy. Now, we have a y squared dy, So we'll make our substitution on that, and we'll get 1/3 du. Performing that substitution will give us the following. We'll worry about the bounds in just a moment. The square root of y cubed plus 1 will become the square root of u, and y squared times dy will become 1/3 du. For the bounds, we plug in y equals 0, we get u is equal to 1. We plug in y equals 1, we get 1 cubed plus 1, u will be 2. Let's take the 1/3 outside of the integral. We'll treat the square root of u as though it's u to the 1/2 power. That'll give us u to the 3/2 power times the reciprocal of that, that's 2/3, going from 1 to 2. Taking the 1/3 and the 2/3 and combining them together, that'll be 2/9 times 2 to the 3/2 power minus 1 to the 3/2 power. There's not a whole lot else to do with this other than maybe simplify these things a little bit. We'll convert it to one big fraction. We'll put the 2 on top, the 9 on bottom from the 2/9. 2 to the 3/2 power is the same as saying 2 square roots of 2, and 1 to the 3/2 power is the same as saying 1. So we'll say that our final answer for this one is exactly what you see on the screen there. 2 times the quantity, 2 square roots of 2 minus 1, all over 9.